All right, so now we are going to continue with our summary videos. And again, I want to remind you that a little bit change to how we've been doing the lessons in class. Because we are doing the investigations in class, the videos are going to be more of a way to summarize what we've talked about in class and show you examples of how these are going to be asked on quizzes and tests. So in addition to the suggested problems that I have for you, I want to make sure that you see a few examples worked out for you as well. All right, so lesson 4.1 is what we started off with today, and the conjecture that we discovered was the triangular sum conjecture. And what that is that the sum of the measures of the angles in every triangle, no matter what size, what kind, what shape, anything, the angles are always going to be 180 degrees. Make sure that when you're talking about angle measures, you mention the degree symbol. On the papers for some of you, that was forgotten, so we want to make sure we do include that. All right. Let's take a look at some examples of the kinds of questions you can expect to see and how knowing the triangular sum conjecture will help you solve them. One of the things we are going to talk about is, with our conjectures, the triangular sum conjecture, we're solving for missing angles. Usually that's one of the primary reasons we have for it. So, for example, on the left-hand side, we want to find W. So up here in the corner, we're going to solve for W. Well, looking at the triangle, we see a couple of triangles actually happening. We have a large triangle in which we could figure out, with some difficulty, we could figure out the measures of this angle for that large triangle. But notice that we already have a measure here. That little box tells us it's a right angle, so that means it's 90 degrees. So that's already one angle of the three that I needed to know. And using a conjecture we worked on from chapter 2, we have the linear pair conjecture, where this 48-degree angle plus this large angle here is equal to 180 degrees. So let's figure out what the large angle is. So 180 minus 48 would be 132 degrees. And then because that's being split evenly between two congruent angles, 132 divided by 2 is 66 degrees. So the measure of that angle is 66 degrees. And that's good for us to know because now I have the two angles I need in order to find the third. So algebraically, what this looks like is I can say 90 degrees plus 66 degrees plus W is equal to 100. So add the two angles we know and subtract from 180. Another shortcut is, for any right triangle, since we already know that one of the angles is 90 degrees, that means the remaining two must also equal 90 degrees. So you can subtract 66 from 90, and that's a little bit easier to do mentally. So that would be 24 degrees. So W is equal to 24 degrees. And again, don't want to forget the degree symbol. Just like with any unit of measure, we need to talk about what that measurement is. Are we talking about inches? Are we talking about centimeters? Are we talking about pounds? All right, in this case, when we talk about angles, we are discussing degrees. All right, let's take a look at the second example. It says, find the sum of the measures of the marked angles. So the marked angles are these pink ones on the outside here. Now be careful with the markings. Notice that there are no dashes, all right, to tell us that these three angles are congruent to each other. They look pretty similar, but we can't verify that with certainty because we don't know the measurements of the interior angles and we don't know the length of the sides. If I knew some of that stuff, I could start to surmise with some of my future conjectures what those angle measurements are, but since we don't, we can't really find the individual angles. But that doesn't prevent you from finding the answer to this question. There's two things we need to know. Notice, obviously since this is following the lesson about triangular sum theory, that we have 3 angles on the inside. And we know that the sum of those 3 angles is 180 degrees. So off to the side here, I'm just going to write the names I've given those 3 angles, showing that the sum of that is 180 degrees. Now also, I know that angle y plus that unknown pink angle is a linear pair. So that means that's 180 degrees right there. And same thing with angle x and the unknown pink angle. That's 180 degrees because it's a linear pair. And same thing for the third angle over here. They're linear pairs, so that means that's 180 degrees. So using the linear pair conjecture, I know that I have 3 sets of 180 degrees. But I want to know what those 3 angles on the outside are, so I can subtract the interior angles, which from the triangle sum conjecture, I know that's equal to 180 degrees. So using some basic algebra, I have 2 sets of 180 left over, which would be 360 degrees. So even though I don't know exact angle measurements, I was able to use those 2 conjectures to still solve the solution. All right. Now again, if at any point I'm going too quickly for you, pause, rewind, go back. Make sure you pause at the beginning of each question so you can copy down the shape to look at it and work on it by hand. So for example, this next image is pretty complex. This is a common type of question to ask where we have a lot of things going on and you're asked to find the measures of a bunch of different letters. Step 1 is that you want to organize what letters you're looking at in order. So we see M, N, P, Q. So we're pretty much guaranteed we're going in alphabetical order here. Now notice that I skipped over O. O is actually not used as a variable because it's too close to the number 0. We don't want confusion between O and 0. So we don't use the letter O as a variable, so we'll skip over that. But we do have everything else all the way up to U. So when you're putting your final answer together, put it in this nice alphabetic order. Plus it also is just kind of a nice easy way to give you a checklist. Because when you go to solve the problem, you're not necessarily going to solve it in alphabetical order. Sometimes it doesn't work out that easily for you. Sometimes it does, but sometimes it doesn't. In fact, I tend to not solve mine in alphabetical order all that frequently. All right, so what we're looking at here is that we see a number of shapes going on, lots of different triangles. And in fact, there are triangles within triangles. So that's going to be necessary for us to look at. Well, the first one that's easy to find is up here with N. We have a right triangle, we have 60 degrees. That means the third angle is 30 degrees. All right, so nice and easy to start us off with. And then going straight into the other right triangle over here on the left-hand side, 90 degrees plus 40 degrees means 50 degrees is left over. And then using the vertical angles conjecture, that means N is 50 degrees. I'm going to simplify, or not simplify, I'm going to make the marker thin out a little bit so it's easier to write inside these tiny spots. All right, so now we got to find some other angles. I think it's fairly simple to go ahead and go straight over to P. May not seem that way since, well, actually it's the next alphabet, so that kind of makes sense, I guess. Vertical angle tells me that's 30. A linear pair conjecture tells me this angle right here is 68 degrees. So 30 plus 68 is 98. So 180 minus 98 degrees gives me 82 degrees for this here. And then using vertical angles, that tells me P is 82 degrees. Okay, so I used a couple of conjectures. Use 3 in this case, linear pair, vertical angles, and the triangle sum theorem. Now using vertical angles, I can figure out that This angle right there is 70 degrees. So using this triangle, I have 82 degrees, 70 degrees. That's going to tell me 82 plus 70, and you subtract that from 180. Q is going to be equal to 28 degrees. So far, we're actually going ahead and moving in order. Surprising. Sometimes it doesn't work that easily. All right. The next one I see that's fairly easy is actually, if I take a look here at this triangle, hopefully you followed where I came from with that triangle. I have angle 58 degrees, I have angle 28 degrees. So if I add those two together, not 58 degrees, sorry, that's supposed to be 50 degrees. So 50 plus 28 is 78, subtract that from 180, that tells me this angle right here is 102 degrees. So that tells me, using linear pair, that angle S is 78 degrees. So I've skipped ahead for just a moment to get that measurement. And then, using vertical angles again, I can figure out that the angle opposite of angle S is 78 degrees. So I have 70 plus 78, that's going to be 148. So then the difference is 32 degrees for that angle. And then voila, vertical angles coming to save us, 32 degrees for angle R. All right, so let's find angle T. Okay, angle T is kind of hanging out here. In fact, I'm going to switch up my colors a little bit to hopefully find it a bit easier. So I have this triangle right here. That pink may be a little bit harder to see. And we know that this angle, so I'm going to kind of take it out just for a minute to draw for you. This is why you want to use pencils and try and write as neatly as possible. It gets pretty crowded in there. So this angle down here in the corner is 32 degrees, and the one up at top was 30 degrees. So add those together, you get 62 degrees. So then 180 minus 62 gives us 118 degrees. So T is equal to 118 degrees. Now let's find U. Okay, so T is equal to 118 degrees, that's here. That means the linear pair is going to be the supplement, which is 62 degrees. We've already figured out that angle S is 78 degrees. So 62 plus 78 would be 140, which means this angle is 40 degrees. So then the vertical angle is 40 degrees. And we're back at our right triangle. So 90 plus 40 plus 50 would give us 180 degrees. So a lot of work to show, a lot of adding and subtracting going on there, and looking at the big picture and finding the triangles within the triangles to help us to solve the problem. But once I've solved it, now I have all of those answers, and it's the final solution is in a nice, organized manner. So that's what we're looking for. Don't leave your answers here in this work, because that, frankly, is just a lot of busy, crazy action going on there. All right, so we're going to clear off the screen, and this is the conclusion of lesson 4.1. So let's move on to 4.2. See you on the next video.